Good morning, students. Jai Swaminarayan. In the last lecture, I think we have completed up to 10th of exercise 6.1. Today, students, we will complete exercise 6.1. I think in the last lecture, we have completed up to the 10th sum of exercise 6.1. Today, students, we will do the remaining sums and conclude the exercise and the topic. A particle moves along the curve 6y is equal to x cube plus 2. A particle moves along the curve. So, exercise 6.1, answer 11. Students, given curve along which a particle moves is 6 times y is equal to x cube plus 2. So this is our result. Find the points on the curve at which y coordinate is changing 8 times as fast as the x coordinate. We have to locate a point on this curve. Suppose Px, y is the required point on the curve such that, now students, what condition is given, that is very important. What is given? Y coordinate is changing 8 times as fast as x coordinate. Rate of change of y coordinate is dy by dt. Rate of change of x coordinate is dx by dt. And according to given, the rate of change of y coordinate is 8 times the rate of change of students x coordinate. This is students what is given and what we have to perfectly understand. Now differentiating one with respect to t, not x. 6 times dy by dt is 3x square dx by dt. And according to given, dy by dt is 8 times dx by dt. So this is equal to 5x square dx by dt gets cancelled. 3 1s are 3 2s are. So x square is 16, which implies x coordinate is plus or minus 4. Students, x square is 16. So x coordinate is plus or minus 4. Now substitute this in the curve. Substituting x is equal to 4 in equation 1. 6y is equal to 4 cube plus 2, so 66. So y is equal to 11. So the first point is P, x comma y is equal to 4 comma 11. Then students, substituting x is equal to minus 4 in 1. So 6y is equal to minus 4 cube plus 2. So that is minus 62. So y is equal to minus 31 by 3. So the second point is say q, x comma y is equal to minus 4 comma minus 31 by 3. So this are students the required points on the curve according to the given condition, students. So this type of question is very important, students. These are easy sums. I have been repeatedly telling in exercise 6.1 we do not have any prescribed formula, but generalized concept of differentiation and formulas of area volume students are applied in the sum. Okay students, now we will do sum number 12. Okay students, now we do sum number 12. The question is, radius of an air bubble. Now students, air bubble, I think you might be considering frequently in physics as well as chemistry. Students, air bubble. Radius of an air bubble is increasing at the rate of half centimeter per second. Students, air bubble is always spherical. Answer 12. Air bubble is always sphere. So, the radius of an air bubble is increasing at the rate of half centimeter per second. If r is the radius, dr by dt is 1 by 2 centimeter per second. dr by dt is given as half centimeter per second. At what rate is the volume of the air bubble increasing? When the radius is 1 centimeter. So when r is equal to 1 centimeter, we have to find the rate of increasing volume, that is students dV by dt. So students, this we have to find. Now students, what is volume of a sphere? All of you know students. Volume of a sphere is V is equal to 4 pi d pi r cube. Differentiating with respect to t. Differentiating with respect to t. So dV by dt comes out to be 4 pi r square dr by dt. 4 pi r square dr by dt students. Now r is given 1, dr by dt is given half. So substituting this values, we get the answer as 2 pi centimeter cube per second. So the rate in which volume changes, or rate of change of volume, is students dV by dt is equal to 2 pi centimeter cube per second. Okay students, sum number 32. A balloon which always remains spherical has a variable diameter. Okay students, diameter if I call as d, then diameter is equal to 3 by 2 into 2x plus 1 units. We don't know what is unit. So in general students, we write here this many units. Balloon, air bubble, all the students are spherical. So radius will be half the diameter. So 3 by 4 into 2x plus 1 units. Find the rate of change of volume with respect to x. We have to find rate of change of volume with respect to x. So here I do not have to differentiate with respect to t or r. I have to differentiate students with respect to x. So again, volume of a sphere. Students, what is the formula to find volume of a sphere? is 4 by 3 pi r cube. So 4 by 3 pi into 27 by 64 into 2x plus 1 the whole cube. This is the formula to find volume of the given sphere. This is, students, the formula to find volume of the given sphere. Now we have to differentiate with respect to x because we need dv by dx. So differentiating with respect to x. So dv by dx will be 4 pi into 27 by, okay students, dx cancel into 2x plus 1 the whole square into 2. So this will be, you can see 8 is 27 pi by 8 into 2x plus 1 the whole square units. Because in general we don't know what is the unit of radius, so we cannot say what will be the unit of dv by dx. So we write the answer as the generalized answer. Okay, students. Now, if sphere is considered, you cannot ignore hemisphere. Students, volume of a hemisphere will be, students, let me consider this because this is also a very important topic. A hemisphere has volume as 2 by 3 pi r cube. Surface area of a sphere is 4 pi r square. Surface area of a hemisphere is 2 pi r square, and if it is a closed hemisphere, then 3 pi r square. Students, please do write this formulas also, because as far as rate of change is considered, we have lot of sums which have been based on hemisphere also. Unfortunately, in this old textbook it is not given, but you can see new textbook of Gujarat board which was there according to the semester. Students, we had lot of sums, students, based on hemisphere. So be careful. Note down these formulas in your fair book wherever you are writing. Okay, students. Now we go for sum number 14. Okay, students. Now exercise 6.1. Students, we are doing sum number 14. Let us read the question. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. Pipe. Students, all these concepts are very interesting and very important to understand. As far as pipe is concerned, pipe is a cylinder. Even if I say this marker, then this marker is also a cylinder. So, what is the given data? Sand is pouring from a pipe at the rate of 12 centimeter cube per second. 6.1. Answer 14. We collect the data according to D1. dV by dt is 12 centimeter cube per second. So, sand is being poured from a pipe, and pipe is always a cylinder. Volume of a cylinder, so it's just for your knowledge, volume of a cylinder, all of you know only, it is area of base which is circle into height, so it will be pi r square into h. Always volume of any figure is area of base into its vertical height. So volume of a cylinder, students, is pi r square h. But here the sum is altogether a different aspect. Sand is being poured at the rate of this. The falling sand forms a cone on the ground. Say suppose this is the pipe from which the sand is poured, and the falling sand forms a cone like this. This is the vertical height, and so this is the radius of this. Here the sand is falling. So it is given such that height of the cone is always 1/6 of the radius of the base. H is equal to 1/6 into r, or r is equal to 6h. This is students. So again, in this type of sums, data collection is a very important aspect. Unless and until students you understand the question in this type of sums, it will be difficult to solve. Further, how fast is the height of the sand cone increasing when the height is 4 cm? When h is equal to 4 cm, we have to find dh by dt. When h is 4 cm, then we have to find dh by dt. This is what we have to understand, students, and what we have to obtain. Now, cone, all of you are taught this in 9th standard. Volume of a cone is 1/3 of the volume of a cylinder. So, volume of cone is 1/3 pi r square h, where r is the radius of the base and h is the vertical height. So, I start with volume of cone. V is 1/3 pi r square h, and I find that r is equal to 6h. So 1/3 into 6h square into h, and this is 36 pi by 3 h cube. So 12 pi h cube according to the given condition. Now, differentiating with respect to this is volume. So differentiating with respect to t. So dV by dt is equal to 36 pi h square dh by dt. dV by dt is 12. This is 36 pi h square is 16 into dh by dt. 12 minus 12 is so dh by dt is 1/48 pi centimeter per second. Very less, but it is increasing. 1/48 pi. So this number is definitely less. But then also students, the height of the cone is increasing at this particular rate. So students, remember these two formulas: volume of a cone and volume of a cylinder. Just now we have discussed volume of a hemisphere and surface area of a sphere and surface area of a hemisphere. Now students, the next two questions, or in fact next three questions which we will do at a stretch, are topic based on commerce. Now students, cost function. Answer 15. Cost function. The total cost Cx in rupees associated with the production of X units is given by. So we are given, students, a cost function, and that function is C of X is equal to 0.0 0.007 x cube minus 0.003 x square plus 15x plus 4000. In business terms, cost is always dependent on production. Find marginal cost when 70 units are produced. When x is 17, find marginal cost, which is always dc by dx. Students, this are pure commercial topics. What I can say or what I can explain at this moment is this: in business, cost is directly proportional to number of units produced. That students, all of you can perfectly understand. The more you produce, correspondingly the cost increases. So cost is a function of production, and the formula to find marginal cost is dc by dx. This we have to memorize. There is no derivation given for this. In one or two examples they are used. So what I am discussing, marginal cost, and the next question in the 16th sum, marginal revenue. These are, students, pure commercial topics. So at present I cannot explain you what is marginal cost, but definitely I can say that cost is a function of number of units produced, which is x, and the formula to find marginal cost is nothing but, students, dc by dx. So differentiating with respect to x, say I call this as result 1. Differentiating 1 with respect to x, we get dc by dx is equal to 0.021 x square minus 0.006x plus 15. Okay, students, I hope it is 0.003x square, correct? Okay. So what we were supposed to remember, the formula to find marginal cost is dc by dx. The next sum is based on marginal revenue. Now in business, revenue collected is also dependent on sales, which is given by x. So students, you have to perfectly remember this formulas. These are commercial topics, so we are not going into much detail. So when x is 17, dc by dx we have to obtain, and that will be 0.021 into 17 square, 0.006 into 17 plus 15. Simplify using the calculator. That means this is your answer. 289 into 0.021 and minus 0.006 into 17 plus 15. Students, using your calculator, you can do the sum. Simplified answer. The total revenue in rupees received from sales of x unit. So 16 sum is based on marginal revenue, and writing here, students, answer 16. So revenue function Rx is equal to total revenue rupees received from sales of x units of a product is 13x square plus 26x plus 15. 13x square plus 26x plus 15. Again, students, in business, whatever revenue you obtain or you get on sales of x units is given by Rx, and definitely revenue will be a function of sales. Sales is always, students, in number of units. Sales, students, is in number of units. Obtain the marginal revenue when x is equal to 7. So when x is equal to 7, we have to obtain marginal revenue, which is dr by dx. If it is marginal cost, then students, it is dc by dx. And if it is marginal revenue, students, it is dr by dx. So differentiating with respect to x, I call this as result 1. Differentiating 1 with respect to x. So dr by dx will be 26x plus 26. When x is 7, marginal revenue dr by dx will be 26 into 8. 6 8s are 48. 16 and 4 20, so 280. This is your marginal revenue, students. So very easy. These are the topics which are used in commerce, but from derivative point of view, students, we have to only remember that the formula for marginal cost is dc by dx, and the formula for marginal revenue, students, is dr by dx. So this completes our long sums of, students, exercise 6.1. You can say as such first exercise in your syllabus where you do not have any prescribed formulas. As such, this is the only exercise in your syllabus of mathematics, students, where we do not have any prescribed formulas. Okay, let us do MCQ 17 and 18. MCQ 17. The rate of change of area of a circle with respect to radius. So dA by dr when r is equal to 6 centimeter. Students, we are told to find rate of change of area with respect to radius when radius is given 6 centimeter. What is the formula to find area of a circle? Then we can write area of a circle is A is equal to pi r square, differentiating with respect to y. So dA by dr is 2 pi r. Substituting r is equal to 6. This becomes 12 pi centimeter square or centimeter. Students, units are never to be cancelled. Don't write centimeter square upon centimeter. That is mathematically absurd, because students, we never cancel units. Okay. Again, the next question is based on marginal revenue. So the total revenue is received from sales of X units of a product is given by, so revenue function is Rx is equal to Px square plus 36x plus 5. Find marginal revenue when x is 15. We have to find, students, dr by dx. Now, just now, students, I have taught So again, I am discussing differentiating with respect to x. We get 6x plus 36, taking x as 15. 90 plus 36 is 126 rupees. This is our answer. So, in 17th MCQ, according to the option, the correct option was option B. Students, that I didn't write. But you can easily do this much on your own. And in the next MCQ, the correct option is option B. So this completes exercise 6.1 and the topic of rate of change. This completes, students, exercise 6.1 and the topic of rate of change. What I told is very important: cylinder, hemisphere, sphere, cone, surface area, curved surface area, lateral surface area is same as curved surface area for cone is pi r. Slant height L is equal to under root of r square plus h square. Students, lot of formulas are involved in this topic. Lateral surface area or curved surface area for cone is pi r L. L is the slant height and L is equal to under root of r square plus h square. This also, students, you will remember, memorize and apply as when required. Okay, students, thank you. We conclude the lecture. Remaining students we will take in the next lecture. We will start increasing decreasing function in the next lecture.